All right, this video is going to go over the problem that we started and went over a little bit in class, but I want to make a video on it so that you can sort of slow it down and make sure that you completely understand it. So we're asked to graph first y equals 7 times the sine of 2x plus 3. So if I ever ask you to graph r equals 7 times 2 theta plus 3 or something like that, you should graph the rectangular form first, so with y and x. So y is r and theta is x. Okay, so you should graph the rectangular form first. So here's that graph. The period is something we should say is pi. So I broke my scale up into pi over 4s, and I put my axis of wave, and we put that in like that. Okay, so first you need a very accurate rectangular coordinate system graph. All right. Now we're going to transfer this graph down into the polar form. Okay? So the way I like to do it is to go point by point. Don't necessarily have to make a table. I just go point by point. So the first point here is r is equal to 3 and theta is equal to 0. So the first thing I did down here is I made a scale. I'm making this video here, so I made a scale so that I got as high as 10 here. So r is 3 and theta is 0, so I put that point right there. All right. The next point here, the angle is pi over 4 and the distance is 10. So pi over 4 is right here, and we need to go to 10, which is right here. Okay, so, and I know it curves because I know this graph is not a straight line, it's a curve. The next point is right here, and that is an angle of pi over 2, so we're talking about right here, and a distance of 3, so that would be right here. Okay, so I know it kind of goes like that. All right, here's where it gets more complicated. So we just plotted this point. The next point is 3 pi over 4 negative 4. So 3 pi over 4 is right here. But since the distance is negative, we're not going to go along this path. We're going to go the opposite way. So this point, 3 pi over 4 negative 4, is right here. So we know that between this point and this point, which corresponds to here and here on the rectangular graph, we hit a distance of 0. That means we have to go through the pole here. And so I'm going from here to here, and I'm going to cross through what we call the pole. We don't call it the origin, we call it the pole. So it's going to kind of go like that. All right. Next point is pi 3. That's going to be right here. And again, from this point to this point, we have to go through the pole, because from this point here to this point, we go through the x-axis. And so we go from here to here by looping through the pole and going like that. Okay, it's kind of hard to get it exact, but we know it does something like that. All right, so we're at pi. 5 pi over 4, 10. That's pretty straightforward because it's not a negative distance and we don't go through the pole. It would be right here. And so it's going to kind of keep going like this, kind of symmetrical to how it does over here. And then 3 pi over 2, 3. Again, that's here. We don't have to worry about going through the pole, so we're right like that. And then we're at 7 pi over 4, negative 4. So that's going to be 7 pi over 4 is right here. But we have to go this way because it's a negative distance. And so that's right here. And so between this point and this point, we have to go through the pole. And so I'm going to go here through the pole and kind of loop this way. And then the last point is 2 pi 4, which is where we started. So we have to go from this point to this point by going through the pole again. So we're going to loop. We can see the symmetry occurring here like this. So there's our graph. We've got two sort of big loops, which are represented on the rectangular graph of these two sort of things right above the x-axis, and we've got two little loops, which are represented by these little things right there. Okay, so hopefully you can use this video to slow down. I went pretty fast, but you can pause it and back it up and do whatever to make sure you understand how to do this. Because if you can do this graph, you can pretty much graph any polar graph. Some of them might be a little bit more intricate and involve a period that's smaller, so it may do a lot of wacky things, but this is our general process.